about the master set at 21.
Yes.
I wasn't sure where to find stuff about how current affects light bulbs.
A light bulb, especially the classic light bulb, it's basically it's a resistor.
Okay.
And
I guess that was my question.
because you're losing energy on a light bulb, that energy gets converted into heat, and some of it actually shows up as visible light. About 10%. They're not particularly efficient.
You can treat it as a resistor.
Yes.
Okay.
And the fact that most of it ends up being the energy loss that goes into heat is the essence of the easy bake oven. Gina?
Can we go over one that's similar to number 3 on the master set 21? I did it, but I don't know if I did it correctly. I did it using substitution.
Number 3. Yes. And I will tell you that the last problem on test 1B will be something very much like that.
Also, question. On the calendar it says that test 1B is Thursday.
Yeah, we need to talk about that before we're done here, so hopefully we'll get a few more stragglers and then we'll deal with that. But let's make sure we don't leave without talking about that. All right, so you're gonna have there's gonna be 3 batteries. Batteries might be facing up, facing down. So first off, on a battery, which is the positive side, which is the negative side?
The longer one's the
The longer ones.
The longer one is the positive one?
Yep. Is that what you said, Gina? All right, so they'll either be with positive side up or positive side down. It depends. So I'll have one here, and one here. Those. And so let's give it some voltage, 2 volts, 5 volts, 6 volts. And there's gonna be a resistor here, a resistor here, a resistor here. And I think typically out of the battery, the resistor would flip there. So let's stick the resistor here. And I think the other one's up here. Now, in the master set, the design that I have, the way it's written, it's because I was having issues with drawing it. And I just said, you know what, that's close enough, it's a circuit. And then later on, I took the time and it now looks more like that. We need resistances here. Now, because I'm making numbers on the spot, we're gonna get some fractional currents, and that's fine. On the test, sometimes I ask, do you wanna make sure that the answers are integers, or do you care? And the advantage of if they're integers is that you get all integers through the answer, you probably feel pretty good that the worst you get is making some tiny little error. The downside of knowing that there's gonna be integers as the answers is that if you don't get integers, you know you did something wrong, and you can let that haunt you. 3 ohms, 1 ohm. If I start using a 6, I'll use a different number. Got 1, 2, 3, 4, 7 ohms, and make that 10 ohms. And probably made note of this in one of the videos, but this is absolutely horrible design. There's no reason why you would actually design it this way. This is just a mechanism for learning the process. All right, step 1. Decide which technique you're going to use. Do you want the 1 current per path or 1 current per loop? Per loop? All right. So I'm just gonna arbitrarily, doesn't matter if I go clockwise or counterclockwise, so I'm gonna call this I1 or IA, and call this one IB. And again, probably stated in one of the videos, whichever technique you want to do, pick one, learn how to do it. Trouble comes in, people mixing and matching. When you're doing the one current per loop, you're not gonna use the junction rule because it's already sort of built in. Now, we need to come up with, I have two unknowns, I need two equations. So we're gonna come up with our voltage loops. So we have a choice of three primary voltage loops. We've got the left side, the right side, or the whole thing. Which one do I want to do first?
Left.
All right. So again, I don't like the first one to be negative. That's just a me thing. So I'm going to start here, and I'm going to go that way. So I'm going from the negative to the positive on the battery, so I'm gaining potential. So that's 2. Cruising along, come across this 3 ohm resistor. I'm going against the current here. So what's the potential difference across here?
3 ohm plus
Sorry,
3 ohm?
you said 3 ohms?
I think so, instead of negative, it would be positive.
Okay, it is positive. It's not 3 ohms, it's not different. That 3 ohms is the resistance.
With 3 IA.
Yes, there we go. So plus 3, and let's just go ahead and A is equal to A sub I, and B is equal to, or I sub A, I sub B. Just because I don't feel like writing. Plus 3B. All right, cruise along here, we're doing the left end, we're going across the battery again.
Plus 5.
Going across the 1 ohm resistor, I'm going against IA, and I'm going against IB. It's got 2 currents flowing across here.
Would also be plus 1 IA.
So, you said plus 1 ohm?
Plus 1B.
And then over the 7 ohm,
7 ohm.
Plus 7.
yeah, plus. And then I'm back to where I started, equals 0. One equation down. Now, since everything is positive, I feel pretty confident that A and or B will be negative. At least one of them has to be negative. If I had to guess, I would say that B is probably going to be positive and A is going to be negative, but we'll find out. All right, so that's the left side. Now we have the whole thing or the right side.
Whole thing.
All right, let's start in the same place, because that way I don't have to think about the first 2. It's 2 plus 3B. Cruising along, get over to here.
Plus 6 ohms.
Plus 6. Going across the 10 ohm resistor.
You're going with, right, so.
Yep, I have my current flowing this way.
Negative 10B.
So with the current, because water flows downhill, so if you're going with the current, you're going down, so subtract minus 10B. Now across the 7 ohm resistor, and we're back to where we were, so plus 7A is equal to 0. The most common mistakes I see at this point is, Well, getting a plus or minus in the wrong spot. Because that will completely change the answer.
Would it be 3B or 3A?
Here,
Yes.
they should both be 3A. Any other mistakes? Let's see, so 2 plus 3A plus 5 plus 1A plus 1B plus, sorry, current flowing that way, plus 7A. And then for the whole thing, you got 2 plus 3A, thank you, plus 6 minus 10B plus 7A.
Yeah.
And we can always double check. Of course, I would not have caught that mistake. We have one other check in the fact that I could subtract the two equations and see if I get the right-hand equation. All right, so two equations, two unknowns, now what?
You pair the similar ones.
Say it again, Gina?
You pair this similar, so basically A with A's.
Okay, combine like terms.
Well, yeah.
Okay. Yeah, before we pick that technique, we gotta simplify it. All right, so I got a 2, 5, and 2 and 5, so I got 7. My A's, got 3A, 1A, 7A, so that's 11A. And then plus 1B equal to 0. And then for this one, I've got 2 and 6, so I've got 8. And A's, I got 3A and 7A. So it's plus 10A minus 10B equal to 0. All right, so now let's pick a technique. How do we want to solve for A or B? And we can mix techniques.
Substitute.
Is that what you say?
Substitute.
Okay. So, since the easiest one is to solve for B here, is because I don't have to do any dividing. So from this one, I see that B is equal to negative 7 minus 11A. Plug that into the second one. So 8 plus 10A minus 10 times negative 7 minus 11A equals 0. Distribute 8 plus 10A plus 70 minus the plus 110A equals 0. So I have 78 plus 120A equals 0. And we end up with A, probably don't need it that big. A, which is I sub A, is equal to negative 78 120ths. Unless there's a Carroll's error, which, you know, these problems really love Carroll's errors.
Negative 0.65.
Amperes. So this is a unit right here, and this is just a shorthand for I sub A. Of Questions up to here, before we put the last nail in the coffin?
How did you determine the direction of the currents?
I picked one.
Okay,
It's completely arbitrary.
alright,
If I had picked IA in the other direction, then the A terms here would have all flip signs. And in the end, we'd end up with A is equal to positive 0.65.
do you want them going in opposite directions?
Nah, I don't care.
Alright.
So we get to choose where the current goes?
Yeah.
Okay.
Which is part of the problem with solving these, is the fact that there's so much choice there that, I mean, some students, I had one class in particular that they sort of en masse, I think they were studying together outside of class. They picked one technique, and I think all but one student did the exact same technique. They picked the arrows going in the same direction, all of them, because they learned how to solve it one way. I think that was the class where more than 50% got the problem completely right. All right, so B, well, we have a formula for B. B is -7 minus 11A. So -7 minus 11 times, depends on if you like the fraction or the decimal,
0.15.
0.15. So what we're claiming is that we gain potential going, actually, I had current flowing this way, so current's actually flowing the other way. So if I go across the 3 ohm resistor in that direction, I'm gonna lose potential. And my drop here is going to be my current times my resistance. So negative 0.65 times 3. Negative 1.95. The current, well, actually, and let me do the last bit. On the test, the way I want you to present your answers is current, direction, and then the 3 ohm. My current is going in to the right, and it's 0.65 amperes.
Do you have the little table there, or would we have to make it?
The table will be there.
Okay.
And then for the 7 ohm, 0.65 amperes. And I originally said it was going to the right, but because it's a negative, it's going that way. The 1 ohm resistor. All right, well, I originally said that A was going, that they're both going down. But since A is negative, that's actually 0.65 going up, and the other one was 0.15 going down. So what's the net current? Like 5 amperes up. And the 10 ohm resistor. I said B was going to the left before, I got a positive answer, so 0.15 left. And I don't think did I ask for the voltage or potential drop across one of the resistors on the master set?
Yes.
Yep.
Okay. I flip back and forth which one it is, so if I did potential drop across the 3 ohm resistor, delta V, a little tweet there to indicate which one I'm talking about. It is to the right, negative 1.95 volts. monthly units there. And with all of these, I go and have the arrow in the opposite direction for every single one of them if I just change the sign. So, for example, this one right here, I could have also done negative 0.5 amperes down. Those are the same answer. And that's supposed to be negative there. So eraser. Suddenly changed colors on me. No. Apparently I have some way of writing white on this without knowing it. I can only do it by accident. All right, so Gina, you started us off on this. Is this what you were looking for?
Yes,
Okay.
makes sense then.
Daniel?
I'm a little bit confused about the direction. Like how we're determining the direction. So is it in the opposite direction that we initially go with?
Right.
It's negative.
We arbitrarily pick a direction for the current flow.
Yeah.
If we get a negative, that just means, oh, it's the other way. We don't have to redo the problem. It's not like we're dealing with friction where suddenly it's going the other way, so friction has to be going the other way.
Alright.
It's
So just the negatives is what switches it, but if it's positive, then it's the direction that we.
that we say.
Yeah. Okay.
And you can sort of look at some of this that, if you think about batteries as pumps, that this is pumping out water faster than this is and this. You know, between these two, this is the more powerful one, so I got a quick gut feeling that that's the direction of the current flow here. For this one, I got two pumps pumping water this way and one pumping it this way, so it makes sense that the current would actually be flowing like that, opposite direction I picked. Now with resistance in there, it can change things, but at least I have an initial gut feeling. So right off the bat, if I thought about it, I could have guessed that probably